Hello, back again. This is Mr. Waters, and I hope you're okay so far with what we've done with geometric sequences. Now we're going to do one or two more examples of geometric sequences, all right? And then we're going to do some geometric sequence problems, similar to ones we had with arithmetic sequences, and that should do it for this video. The last video for today will have to do with geometric series. Okay? All right, so let's see here. So, on a geometric sequence, here is the formula, yes? Now, what if you had this sequence here? 1, 1/2, 1/4, 1/8. You can see here that the terms are fractional, right? And now, if that's a geometric sequence, if it is, we want to be able to calculate what the common ratio is. We want to know a formula for it, an explicit formula for it, and then we want to calculate, let's say what the 11th term would be. Okay? In other words, what is G sub 11? So each of those things we want to be able to get out of this, okay? So first off, if it's a common ratio, we should be able to divide each pair of terms, each neighboring pair of terms, right, to get the same ratio, the same quotient. So 1/2 divided by 1, 1/4 divided by 1/2, 1/8 divided by 1/4. Well, you can see here that 1/2 divided by 1, that's 1/2. 1/4 divided by 1/2 is 1/2. 1/8 divided by 1/4 is also 1/2, right? So we can see here that we're getting the same ratio for all of them. So the common ratio is 1/2, right? So therefore, okay, getting the equation, okay, G sub n, G sub 1 is 1 plus, oops, not plus, wrong sequence, times R, the common ratio, 1/2, to the n minus 1. And there is our formula right there, right? So we'll put that up here. And now we could write it like this, 1 times 1/2 to the n minus 1. And strictly speaking, we don't really need the 1 in front there, of course, but just so that we can see that we haven't forgotten what the first term is. We can see explicitly what the first term is, which is 1. Now, what's the 11th term? Well, that's going to be G sub 11 is equal to 1 times 1/2 to the 11 minus 1, right? So that's 1/2 to the 10, right? And according to Mr. Calculator, that's going to be 1 over 2 to the 10th power, or 1 over 1024. Okay? Now, if you just do 1/2 or 0.5, yeah, okay, so they give us that. So that's 1 over 1024. That would be the 10th term of that sequence. Yeah? Okay, so now, at this point, I'm going to give you guys a couple of problems to try out, or actually just one to try out here. And put the video on pause, right? And then when you're ready, when you've tried it out, come on back and see how this goes. In fact, maybe I'll give you two. I think I'll give you two. Okay, so the first one is going to be 1. So this is try these, and this is going to be number 1. Okay, here's the sequence: 1, 5, 25, 125, ... Okay, so again, we want to know, same problems, what's the common ratio R? What's the formula for it? And we're going to ask, what's the 11th term? So for each of those. And then for number 2, try this one: 3, negative 9, positive 27, negative 81, and so on. Okay? All right, same thing. All that information up there. So put the video on pause and try these out. And you're back. Okay, well, so here you should see that the common ratio here is 5, right? 5 divided by 1 is 5. 25 divided by 5 is 5. 125 divided by 25 is 5, right? The first term is g of 1. So that's r. The common ratio is 5, right? So g of 1 is 1. So g of n is equal to 1 times 5 to the n minus 1. And there is our formula, the sequence formula. What's the 11th term? Well, that is going to be 1 times 5 to the 11 minus 1, which is 10. And then, 5 to the 10th power is pretty big. It's this, according to Mr. Calculator, 9765625, just like that. So that would be, so g of 10, g of 11, I mean, would be equal to that. This guy here, let's divide. Okay, so negative 3, hopefully you can see each time the common ratio is negative 3, because negative 3 divided by negative 9 divided by 3 is negative 3. Positive 27 divided by negative 9, negative 3. Negative 81 divided by positive 27, negative 3. So this is the common ratio that flip-flops back and forth. Anytime, or rather the terms of the sequence flip-flop positive to negative, positive to negative. And so anytime you see a geometric ratio doing that, that means that the common ratio is going to be negative. Okay? So that's still equal to r, though, and the first term is 3. So g of n is equal to 3 times negative 3 to the n minus 1. So there is our explicit formula. Now to find the 11th term, g sub 11 would be equal to 3 times negative 3 to the 11 minus 1, which is 10. Now keep in mind, on the calculator, to make sure it's doing the order of operations right, I'm going to do the exponent first, but I'm going to put the negative 3 in parentheses so that it multiplies, negative times negative times negative times negative times negative. So then that's going to be to the 10th power. That's not to the 10th power. To the 10th power. And that's, because it's an even exponent, it works out to be positive. That's 59,049, right? Times 3 is equal to 177,147. That's the 11th term in the sequence right there. And that's the other 11th term. Okay, very good. So what you guys should do right now, okay, so we're going to try some other geometric sequence problems. If you want to, you can try some of the problems that are on the classwork right now. Okay, all right. So another kind of geometric sequence problem would be something like this. I'm going to put that over there. We're still on geometric. And we had a similar kind of problem with arithmetic sequences. And we talked about arithmetic means. There's also a geometric mean. Okay? But here, we want to insert, as your book puts it, 2, not 3, 2 geometric means between 3 and 24. Now, we'll get to what a geometric mean is generally in a minute. Okay, you may have had that, and you may have had the idea of a geometric mean in geometry. I'm going to define it here slightly differently so that it makes sense in the context of these problems here. Okay, but what they're really asking is they're going to ask you to imagine that 3 and 24 are going to be members of a geometric sequence, and that there are two members between them. So in other words, we want to insert two members of a geometric sequence in between 3 and 24. They would be called a geometric mean. Okay? Now, we go at this the same way we did an arithmetic mean. In order to get at this, we just need to calculate what the common ratio would have to be in order to be able to multiply 3 to get to the next term, and then multiply that by a common r to get to the next term, and then that term multiplied by that to get to a common r to get to the next term. So in other words, we want to know what the common multiplier would be. Well, the way we get at that is we would say, well, okay, so now if we want two terms between, what we're looking at here is a geometric sequence where g of 4 is equal to 24, and g of 1 is equal to 3. So that means we just now go ahead and we solve backwards for the r. We're still going to use g of n is equal to g of 1 times r to the n minus 1, right? Okay, so let's see. So g of 4, so in other words, when n is equal to 4, okay, the fourth term, g of 4, is equal to 24. So we substitute, so g of 4, you understand, would be equal to g of 1 times r to the 4 minus 1. So g of 4, that's 24. G of 1, that's 3, times r to the 4 minus 1. Now we're just going to use algebra to get backwards to the r value. So I'm going to divide. We've got to do this in the right order of operations, though. We've got to isolate. So this, first off, that reduces to, I guess, 3 times r to the third power. Now keep in mind that we're going to work backwards here. So we're going to subtract, rather not subtract, we're going to divide both sides by 3 first. And we saw the same kind of thing when we were solving exponential equations. Oh, that's what we're doing. That's right, we're solving an exponential equation here. So we're going to divide both sides by 3. That's going to be 8. We're not going to have to use logarithms, though, in case you're wondering that. Okay, so we've got 8 is equal to r to the third power, right? Now at this point, I'm just getting, now you might be able to see right off that the cube root of 8, we're going to, at this point, we're going to cube root both sides. Right? Because we want the number that multiplied by itself 3 times will give you 8. And maybe you can see that that's going to have to be r is equal to 2, right? Okay, so there is our r value, and then we can apply, so our sequence formula is g of n is equal to 3 times 2 to the r minus 1, or n minus 1, but more specifically up here we can now apply the 2. 2 times 3 would be 6, right? 2 times 6 would be 12. 2 times 12 would be 24. So the two numbers we have to insert are 6 and 12, which are the geometric means. Okay? Now, what is a geometric mean? Well, a geometric mean for our purposes, formula looks like this. Okay? So the geometric mean for, say, three numbers, A, B, and C, would be G, the geometric mean, would be A times B times C cube root. Right? So the arithmetic mean, you divide by the number of, you add the numbers together and divide by the number of numbers. For the geometric mean, you multiply the numbers together and root it by the number of numbers that you had. So if we had 5 numbers, A times A, B, C, D, and E, right? Then the geometric mean of those 5 numbers would be A times B times C times D times E, fifth root. That's how that works. So it's kind of like the multiplying equivalent of finding a mean. And that kind of operation is called the geometric mean. Okay, very good. Now, let's try one more of these. Okay, one or two more of these. All right, so let's say we wanted to find, let's say one geometric mean. So here's the problem. Insert one geometric mean, right, in between 5 and 20, right? So in other words, that's going to give us this sequence here, 5, and then a number in between, and then 10, right? Because we want one geometric mean. Sorry, wait a minute. This is supposed to be, sorry, I gave you the wrong problem. This is supposed to be 5 and 20. We'll do 5 and 10 next. Okay, so 5 and 20. All right, so as you can see, we've got 3 terms here. So 5 is the first term, 20 is the third term. So we want to know what's the R that'll multiply to get us from 5 up to 20 with one number in between. So we're at the, okay, so that's going to be, so G of 1 is equal to 5. Since there's 3 numbers here, G of 3 is equal to 20. So 20 will be equal to 5 times R to the 3 minus 1, right? So this is 20 is equal to 5 times R squared. Divide both sides by 5. Okay, we get R squared is equal to 4, and oh look, R is equal to 2 again, right? And that makes sense. So now R is 2. So the general formula would have been G of n is equal to 5 times 2 to the n minus 1, right? But then we look up here, oh yes, 5 times 2 is 10, and then 10 times 2 is 20, right? So that is our geometric sequence. Or that is inserting one term in. Now they don't always come out to be even. They don't have to, right? Just like with arithmetic sequences. What if we wanted to put 2 in between 5 and 20? We wanted to insert 2. So we'll do last example of these. Insert 2 geo means. Right, geometric means. So that would be 5 and then 2 here, right? Now this is definitely not going to come out evenly, but we want this to be the 5th, and this is the 1st, and that's the 4th. That's the 4th term in the sequence now. So G of 1 would be 5, and G of 4 would now be equal to 20, right? So let's see here. 20 is equal to 5 times R to the 4 minus 1. And so this is 20 is equal to 5 times R cubed. So that's 4. So r cubed is equal to 4. Now we've got the same thing, except it's r cubed now. So we're going to cube root both sides. To get the r by itself. Right? R is equal to whatever the cube root of 4 is. Right? Which is not an even number. Right? But that's the common multiplier, and you're thinking, well, does that really work? Well, let's try out here. Okay, so we had 5. And then the next number would be 5 times that. So it's going to be 5 times the cube root of 4. Okay? And then the next term would be cube root of 4 times cube root of 4. So that would be, let me make sure I did this right here, 5. Yep, okay. So this is 5, and then this one would, this next one would be 5 times the cube root of 4 times the cube root of 4. This is going to work. Yeah. So this is, okay, the next term is going to be, underneath here, 5 times the cube root of 4 times 4, or 16, right? Now, does that really work? Yep, it does. Because this is going to be, so then this one is 5 cube root of 16, right? Now we should be able to multiply by cube root of 4 again. And this is supposed to be 20, by the way. Keep writing 10. That's supposed to be 20. Okay, so then to get to the next one, we'd multiply that times cube root of 4 again. See, each time we're multiplying by this weird r, cube root of 4. Well, cube root of 16 times the cube root of 4, if we combine them, that's the cube root of 4 times 16 times 4 is 64. Now we can simplify this. Cube root of 64 is 4, because 4 times 4 times 4 is 64. 5 times 4 is, 20. So a little bit of work, but we can always insert any number of geometric means or any number of numbers that we want in between. It's just that this r value may come out to be something, irrational, like the cube root of 4, instead of a nice even number like 2 on the previous one. Okay, very good. Now I think that's enough for this video here. The next one and the last one will be, we'll do one more here. The next one and the last one will be a geometric mean. Will be about geometric series okay? So how about this one? How about you insert 3 geometric means, and between these numbers here, between 5 and 135. Insert 3 geometric means between 5 and 135. Okay, put the video on pause. Try that out. Oh, you're back. Okay, so let's see here. Now we want 3 geometric means. That means we want 3 numbers in between to make a geometric sequence. So that's going to be, so g of 1 is equal to 5. G of 5, 1, 2, 3, 4, 5, the fifth term, in this case would have to be 135. Okay, so now we just plunk everything in. 135 is equal to 5 times r to the 5 minus 1, right? So we simplify that. 135 divided by 5 is equal to 27, right? So that's 27, right, is equal to r to the 4th power. And then, it's supposed to come out evenly. Okay, and then, let's see, did I do that right? Yeah, okay. So then we just take the 4th root. R is equal to okay, that's equal to r to the 4th power. So now r is equal to 4th root of 27. Now we'll take it easy on ourselves here. 27 fourth root is about 2.28. So we'll write this as a decimal, right? So now we'll see if that works. 5 times 2.28 is about 11.4. We multiply times 2.28 is 25 point, that's actually just about 26, times 2.28 is about 59.3, and then times 2.28 is just about 135, right? So each time we multiplied that by 2.28. Now I was hoping that would come out evenly, but oh well. Okay, Sarah, Sarah. Okay, very good. So that's enough for this video. And then there's going to be more of that on the, one more video about geometric sequences. Okay, and then you should, at this point, maybe start checking out some of the problems on the classwork if you haven't done. Bye.